first equation of Maxwell equation, first Maxwell equation. Okay, this will be taken as first Maxwell equations. We are having the four Maxwell equations in the electromagnetism. So the first Maxwell equation is GUASS theorem. Okay, GUASS theorem in electrostatics. Okay, so this mainly tells that if there exists a charge, if there is a charge and there exists field, if there exists field, if there is a field, and that means there exists a charge. Okay, so this will given by the GUASS theorem. Okay, so that means here if we place the charge means there is field. If there is field means there will be a charge. Okay, so here if we place the closed surface in some space where the electric field is there, okay, so then some flux is linked with that closed surface, that must be is equals to what? Here if you are placing one closed surface inside the field, let us consider this is an electric field. Okay, so here I am placing one closed surface. Okay, so when we place the closed surface inside the field, okay, so the flux linked with this area. Okay, so the flux linked with the field lines which are linked with this area, so that means the flux. Okay, so here these are the field lines which are linked with the area, so that is flux. Okay, so this flux, okay, this flux may be 0, may not be 0, may be 0 or may not be 0. That will be depend on field intensity and area also. And okay, so now here he given a relation between the flux and also the charge which is enclosed by this closed surface. Okay, so he given that the number of field lines which are passing through, the number of field lines which are passing through particular area, so that is what? Flux. Here this is a flux. The number of field lines which are passing through this particular area is how many? 2, only 2. Okay, so this is the quantity. Okay, only 2 lines are passing through this particular area, so that is the flux. Okay, so here he given the relation between the flux and the charge, so that is the flux linked to a closed surface, kept in electric field is 1 by epsilon naught times of charge enclosed in the surface. Okay, so here the main thing is what? The flux linking with what? Charge, enclosed charge. The flux linking with what? The flux linking with charge, but that should be enclosed. Okay, so the relation is what? 1 by epsilon naught times. Okay, so it will be written as the flux is 1 by epsilon naught times of what? Charge enclosed in the surface. Charge enclosed. This charge enclosed is mostly important. Okay, so here the charge must be enclosed. Okay, if the charge is not enclosed, then the flux may be 0 or not, 0 or anything. Okay, so let's see here. These are the 6 charges. Let us consider these are the charges which are enclosed by this closed surface. So here we are getting some flux. So that flux is what? 6. The number of field lines which are passing through that particular lines is 6. Let us consider these are the charges. Okay, now here is the closed surface. Okay, now the flux linked with this closed surface is what? 0, because there is no field line which is entering through this area. Okay, so here there exists some charges inside the surface. There is no charge inside the surface, so here the flux is 0. So that's why the enclosed charge 1 by epsilon naught times of charge must be enclosed, then only there exists flux. This is the Gauss law. Okay, so here the flux linked to a closed surface which is kept, the flux which is placed in a uniform field and it is a closed surface. The flux linked is what? Two lines which are linked through this area, and that must be is equals charge which is enclosed by this surface. This is the Gauss theorem. Okay, so now here we have to prove this theorem. Okay, we have to give them some proof for this one. Okay, now see here. For the first surface, okay, so now general formula for electric flux already we know that electric flux for uniform field, for uniform field and uniform E and uniform A, we already have some formula, that is flux, total flux is equals to E dot A. Okay, E dot A. Okay, now for what continuous body, okay, for the continuous for the non-uniform and in general formula. Okay, this is the general formula. Okay, general formula for flux is what? The total flux is what? Integration over E bar dot ds bar, that is EDS cos theta, EDA cos theta or EDS cos theta. This is the general formula. Okay, so this is the magnitude. Okay, it is a vector form. Okay, it is a vector form. Okay, so now the Gauss given that this total flux means phi t, so that is E bar dot ds bar. This must be is equals to what? This must be is equals to 1 by epsilon naught times of charge enclosed. So this is the Gauss law, Gauss theorem. Gauss. Okay, so here depend on this Gauss theorem we are having so many applications, so we can solve so many complicated problems, so which are not solved by the Coulomb's law. So we can solve with the Coulomb's law also, but that is so complicated and difficult, so that's why we are using the Gauss law, that is to overcome the difficulty to sum up all the electric fields. So that we are using the Gauss law, just we are doing only integration. Okay, now we have to prove this equation. Okay, so now Gauss law proof. Okay, Gauss theorem proof of this Gauss theorem. Okay, now Gauss theorem is what? The flux, total flux must be is equals to 1 by epsilon naught times of Q enclosed. Okay, so this is our one. So that means what? The flux, total flux is equals to what? Integration over E bar dot ds bar, so that is equals to 1 by epsilon naught times of Q enclosed. Okay, so now we have to prove this one, so that's why just take left hand side, this is the LHS, so take left hand side and prove the right hand side. Okay, now for this let us consider a charge here. This is my charge Q. Okay, now here the electric field is like this. This is the field which is due to this charge, that means the effect of the charge. Okay, let us consider here I am placing the one closed surface. Okay, so for this point charge, this is a point charge, so for this point charge here I want to take one closed surface, because this is the, here I am taking the integration over the closed surface. We have to take the integration over the closed surface because we are placing the closed surface inside the field. Okay, so that's why here I want to consider one closed surface. Okay, we have to consider one closed surface. So for the point charge, my convenient closed surface is just I am taking the sphere. This is my closed surface. Okay, so now this sphere I am placed inside the uniform field. Okay, so now here this is the electric field direction. Here I have the small area of this sphere, so the normal to this small area gives the area vector. No, so this is my area vector. Now here also this is my area, So this is an electric field direction and this is the normal. So this is the electric field vector and here I have area and this is the normal vector. So this is the area and this is the E. So at every point the both the theta is 0. Here also theta is 0. Here also theta is 0. Okay. So at every point on the surface the electric field and the area vector both are in the same direction. Here we are getting the both are in the same direction. Why? Because here I am for the sphere the radius is same. The radius is same means here r is same means from the charge to this point the distance is same. From charge to this point the distance is same. Here to here the distance is same. Here to here the distance is same. So that's why at a particular distance the electric field is same at every point. Here the electric field is same. Electric field is same. Why? Because electric field is inversely proportional to the r square. So as r is same, so the electric field also same. Electric field at every point is same because at same distance the electric field also same. Okay. So here electric field is same, r is same. Okay. Now here we have to take the left hand side. So first LHS is what? Integration over E bar dot ds bar. Okay. So we have to prove this one. Okay. So here we have to take the at every point we have to write this is the closed surface, no? So we have to take round here. Okay. So this is the integration through the closed surface and electric field and the area. Okay. So now see here we have to take the closed surface. So that is equals to according to Coulomb's law. According to Coulomb's law, we know that the electric field intensity at point r is equals to what? 1 by 4 pi epsilon naught q by r square. Okay. So right here the electric field due to this point charge is what? At particular distance r. So here this is the field which is given by the charge. So the electric field at this point at the distance r is equals to what? 1 by 4 pi epsilon naught q by r square. Okay. And this is the integration over all the surfaces through the closed surface, and here we have to take the small area ds. Okay. Now here we are taking the integration means the summation of the all the surfaces. Here E dot ds, here E dot ds, here E dot ds. This is the small areas. So integration of small areas gives the total area. Okay. So this 1 by 4 pi epsilon it is constant. R is constant. R is same at every surface. Okay. Every small surface. And here Q enclosed also constant. Why? Because we are taking the charge only one. So that's why charge is also same. So that's why 1 by 4 pi epsilon naught is constant. Q by r square is also constant. The variable is what? Only area. So here we are taking the small area ds1, here ds2, here ds3, like that. So only change in the small areas. So but the integration of small area gives the total area. So that is the total surface area. Total surface area of the sphere is what? 4 pi r square. So just write here for integration over the closed surface ds is equals to 1 by 4 pi epsilon naught q by r square into the integration of total surface area is what? 4 pi r square. Surface area of the sphere. So then 4 pi cancel, r square cancel, then closed integral over E bar dot ds bar is equals to what? Q by epsilon naught. This Q must be enclosed. So here if we are taking the LHS and right hand side is proved. So this is proved. Okay. So if you consider here we are only considering the point charge. If it is not a point charge, if it is a dipole, let us take dipole. If it is a dipole, then the electric field due to dipole is what? E is equals to what? 1 by 4 pi epsilon naught p, here we are taking 2p by r cube. Okay, 2p by r cube means here we are taking for the dipole, electric field due to dipole is inversely proportional to the cube of the r. Okay, so in the here we are getting r cube. R cube means r square cancel, and here we are taking q, we are getting q by epsilon naught into r. Okay, so that means it is not proved. So that means what? GUASS theorem only for the point charges and the continuous charge distribution, but not for the dipoles. Okay, so it's not possible for electric dipole. So here we have to write GUASS theorem. GUASS theorem achieved only for electric field follows inverse square law. Inverse square law. So that means it is for only point charges or continuous charge distributions. Continuous charge distributions. Okay, but not for GUASS theorem not possible for dipoles. Okay, so we are not okay, we can use GUASS theorem only for the point charges or the continuous charge distribution case, but here GUASS theorem is not applied for the dipoles. For the dipoles we have to use Coulomb's law only. Okay, so we have so many applications that is by the GUASS theorem. Okay, so for the different charge distributions we are getting the different electric fields, so that's why we have to take the integration of the at one. Okay, so the limitations which are given by the Coulomb's law will be overcome by this GUASS theorem. Okay, so this is about GUASS theorem. Thank you.